industry. I've worked in many capacities. And one of the things I haven't really been able to do a lot is splicing. So I took on this call because I wanted to show you guys it's so easy, a girl can do it. So we want to talk about splicing basics, right? When we talk about our industry, we work in the elements. We work in dust. We work in rain. We work in cold weather. We work in hot weather. And the idea and the strategy is to keep things as clean as possible. For any of you guys that have listened to my test and measurement webinars, the one thing we always promote is cleanliness, inspection, making sure that when we're launching and testing this stuff, that we're doing it in the most optimal conditions. And it starts with cleanliness. So when we talk about fiber basics, it doesn't matter if I'm going to do something as simple as a clad alignment with a splice-on connector, or I do mass splicing with ribbon splicers. It all starts with our environment. If we have the opportunity to put this thing together in a trailer or confined, controlled space, woohoo! But a lot of times if we're trying to put this stuff together in the field and we don't get to predict and control our environment, we still have to work our best at keeping our stuff clean. So we're going to start, we say clean, 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 clean. Before we start for the day, we want to do an arc check on our splicers. This obviously, I'm showing you guys the Fitel line. We represent Fitel, and we'll be using Fitel. But if you're using Fuji, Sumitomo, or another brand, they all arc check. And again, we're talking fusion splicing. So what I've done already is I've prepared my fiber. I've measured it. I'm using the splice holders. I find these to be the easiest way, the most accurate and consistent way in cleaving and splicing and cleaning. They're designed for the ribbon or the fiber size. I'm using some raw fiber that I got from a cable, and it's 250 micron. I've taken off the coating with my strippers. I use mechanical strippers. Then I placed it in the cleaver. I cleaved it, placed it in here, did the same to the left side, and I'm going to just simply do an arc check. What an arc check does is it gets this machine basically ready to work in your condition. If it's really hot, it's going to compensate for that. If it's really cold, it's going to compensate for that. So we're really trying to make sure that our splicers are ready for splicing. Now, the deal is, in our industry, we've gone from service providers taking care of their networks, doing the splicing, doing the building, doing the maintenance, to hiring contractors. And our contractor base is huge. And you guys get paid pretty much for the job, for the fiber, for the connector. And the idea is to be able to work faster, get more done, but be efficient and not be called out to fix things. So to make that happen for you guys, we're going to start today. I'm just going to show you a simple SOC. I want to show you how easy it is. I've already done my arc check. The machine has told me, hey, you're looking good. We're ready for splicing. Some people ask, how many times do I have to do an arc check? I do an arc check if I'm splicing first thing in the morning, and then I'm fine. If I change, let's say, you got to take that splicer down the hill, you changed altitude significantly, you changed conditions significantly, then you might want to do an arc check again. But if nothing changes dramatically, arc check it, get it ready for the day, and it should be fine. We talk about cleanliness. Make sure all your tools are clean. A simple wipe of your stripper, good enough to get rid of any residual buffer coating, and also be cognizant, even though we're just stripping off this coating, we're going to be wearing this down over use. So sometimes it's good to have multiple tools at your disposal when you're doing this. Always, always, always use a fiber, like a glass optimized cleaner. These have, they're designed for fiber optics. They're designed to make sure to protect and keep that glass. Oh Lord, what word do I want to use? It's just, they're fiber friendly. We want to use these products when we're dealing with our glass. You don't want to get our glass dry, brittle. Once you've cleaned it, rule of thumb, when you hear that nice squeak, it's pretty clean. Put it in your cleaver. I'm using the Tensile S326. It's cleaved. We're doing this on the Ninja Splicer. This is a class splicer. So basically, we're going to be aligning the clad on that fiber. We don't have to worry about the core. Clad splicers are great for fiber to the home and for real short distances, because you don't have to worry too much. I mean, the cores are going to align, but you don't have to do too much to make it happen. I'm going to place every SOC. If you have a Fuji machine, if you have a Sumitomo, and you use their SOCs, that's fine too. Follow the instructions because they're all made a little different. Let me get this guy in here, frickin'. There we go. SOCs have already been cleaved. They're already ready to go. I'm going to go place it in here. It's lined up on the cruise. I hope you guys can see that. Go into the menu. This doesn't look like it's going to be a good one. Fusion program. I've chosen the Easy Fuse fusing program. I didn't think that was going to be good. My bad. The beauty of these splicers is the messaging. It lets you know. You can look on it, look on those screens. It pretty much tells you, hey, you can, I mean, obviously you can visibly see that. Are there any questions? There, I'm compromised here with my vision. Understand, each splice is going to let you know what the estimated loss is through that splice. But make no mistake, that's not accurate. I mean, that's not as accurate as if you were to run this through an OTDR and get the actual loss at that splice. To determine actual loss in any splice, you need a source and a meter. But based on the cleave and the heat and the fusion and the way it looks, this one has an estimated loss of 1. A splicer is going to do a tension test. It's actually going to pull some force on that splice to make sure that it's fused properly. And then now I'm going to put on my heat shrink. I'll place it in the oven. My heater's on. On the Tensile, it's going to let you know, hey, it's in the oven. It's going to do a preheat. You can hear little fans moving. And then it will move into a heat mode, and it's going to give you a bar of progress. And then it will do cool down. The whole time I'm doing this, I'm obviously not a master splicer. I don't do this every day. I'm probably a little slow and clunky, but at the end of the day, I'm making sure my environment's clean. I don't have a lot of debris here, and I'm going to have an optimal splice. Now it's cooling it down. It is fused on there. I'm using one of the LC SOCs and the assembly again. You can use manufacturer's instructions. I have my SOC. This is ready to go. You can plug it into any connector. Any questions? All right. My method's no different from working on an SOC or if I'm working on inline splicing and putting two fibers together. This is a core alignment splicer. What's the advantage? Well, clad alignment, you're really just making sure the outside clad is aligned. Core alignment, this obviously has much more technology in it, and it's going to make sure that core is aligned. We're going to use core alignment splicers for long distances. Excuse me. I've already done my arc check this morning on this unit. And now I'm simply going to go ahead, clean, strip, clean, and cleave.
Hey, Tammie.
Yes, sir.
We have somebody who says, how often should the arc check be performed?
The arc check needs to be performed. I would perform it. So if I'm on a job and it's sitting in my trailer and I got to be out there every day for a week, I think it's good practice. Every morning I go in there, I'm going to turn on my machine, I'm going to do a quick arc check. I'm done for the day. If for some reason I need to change my environment substantially, like take it up a hill or bring it down from a hill, so I'm changing elevation, I'm changing altitude. If taking it into a hotter environment or a colder environment, I'm going to want to arc check. But for the day-to-day use that we do, once a day, every morning before you start the day. When we talk about cleaning, everything we're using needs to be clean. When you burn fiber together, like anything, there is going to be a residual. Carbon is created after a fire. And when we use these units, every time it burns in there, it's using these electrodes, there's an arc. You can get deposits of carbon that go straight into that well. It's important that you maintain these units. Same with your cleavers. If you see shards of glass there, make sure they're out of the way. You don't want to damage that wheel any more than you need to. In here, all the electrodes, and I think this goes across all manufacturers, right? You can remove and replace your electrodes. You can sharpen your electrodes. You can remove the carbon that collects on your electrodes. As you use your machine, it's no different than using an OTDR. Use causes wear, excessive wear causes substandard performance. Our job is to keep this stuff working as long as possible and that means to really, really take care of it. This has done its tensile test, tension test. It's pulled out that fusion. I'm going to go ahead and remove it. Put my little shrink sleeve on it. Pop it in my little easy bake oven. It's baking. When we're splicing, again, first step, start for the day, arc check. Doing our arc check, we're still making sure cleanliness. Cleanliness needs to just be on our brain all the time. We're making sure everything is clean. Right here, after stripping, can you see that? Let me see. I have some of that coating on here. Over time, when I'm in a hurry, if I keep doing that, I'm actually going to interfere with my stripping process and leave microscopic particles on my glass. That's going to interfere with proper splicing. It's also going to interfere with bonding right here. If I don't have real good protection on this splice, I'm setting it up for failure down the line. So when we talk about splicing basics, basically, I want to make sure my machine's working as efficiently as possible right now. So I do my arc check. I'm constantly making sure my tool, my cleaver, my splicer is clean. I'm using products that are friendly to the glass. But again, nothing in my process is changing. I need to do mass fusion splicing now. I'm going to do my ribbon. I've put my ribbon in my holders. I'm going to use a thermal stripper. I've already arc checked this morning. Not much has changed. The nice thing about these strippers is it gives us a guide of how long we need this. My ribbon is sitting between those two lines. Close it. This is the Tensile S218R Plus. Flashes green. I simply hold, pull. Cleaning doesn't change. I'm just cleaning more of them. And you can see these get a little gunkier sometimes. I'm going for that squeak. I'm going to cleave it. Place it in my splicer. You can imagine what happens on these ribbon splicers. You're burning a lot of glass at one time. You're going to be creating more carbon deposits. So this little guy's even more sensitive. He's looking at 12 pieces of glass. Got it. Gonna clean it. Wait for my squeak. Pop it in there. Everything fits perfectly. I'm in single mode 12. Everything's fine on my settings. Hit play. Hold on. The industry manufacturers, your fusion splicing manufacturers, it gives you the alignment error. If I were to look in here right now, I can't see because I'm kind of blind from all my years in telecom. It basically said fiber 7 and 8 are out of alignment, and it couldn't put that in there. A lot of times I'm just going to reset those in the groove, make sure the glass is laying perfectly in there. And then this is going to give me a list of the estimated loss between each one of those 12 fibers. I'm going to do the tensile test. It lets you know there's a tension test going on. It's ready, and I'm going to go ahead and remove my fiber. Now, obviously I can't throw this in the heater. I don't have a shrink wrap for my ribbon fiber, but the process is the same. I want to arc check. I want to make sure everything's clean. I want to keep everything clean. I want to make sure my environment is as free of debris and dirt as possible. I want to make sure that I'm protecting this splice. I'm using the proper shrink sleeve. I've got my heater setting perfectly. I've got nice fuses. And then we place it in our trays as we need to go. There's not a lot. When you sit there on some of the webinars I give, when I talk about test and measurement, we can go down rabbit holes on the different scenarios and all this other stuff. But when we get into splicers, this unit does the work for you. You need to know how to talk and understand the functionality of your machine. The menus, how to fix something that's not right, but these are very diagnostic. They let you know what's going on. So the splicing in and of itself isn't the hard part. But the due diligence is on the operator to make sure he's giving this splice a chance at working for the long haul. We want to make sure this stuff, when it's in the ground and it's dug up in 10 years, people are like, dang, that was some good stuff. That's not where the failure was. The failure was downstream. But that's our job, right? You guys are the MacGyvers in this industry. You guys are the ones that have to use oil and gum to make things work sometimes. And your network equipment manufacturers are making sure that we give you tools that don't require a whole lot of training, that really can just plug in and go with a few simple steps. And we just ask for you. Clean, clean, and clean some more.
Hey, Tammie,
Yes, sir.
Could you please show the ribbon in the thermal stripper again, that process? It was a little bit off camera.
Okay. Back in the day, and for any of you on the call that are, splicers from way back, it was clamped. You kind of estimated, you measured it on there, you needed a 12 millimeter, you needed a 10 millimeter cleave. We really try to take that guesswork out of it all. So again, I'm going to talk broadly on fusion splicing manufacturers because I've used Fuji, I've used the Sumi machine, I've used Spitel, I've used other brands. This is key. This is key for training. This makes it easy. So I place my fiber, the hot stripper. I want to make sure before I use this that my plate is clean. The lid, the rubber thing is clean. Every time I strip, you can see down here in this well, maybe focus is kind of hard, but there's little pieces of like dust. So I use the hard nylon brush and just make sure that I have less interference as possible so I have a really nice strip. Place my fiber, my ribbon, all the magnets. Make sure I fall in between this margin. Close it. This will tell me when it flashes green, it's ready for me to strip. Pull it. Open it. Now, this one got a little cruddy. Most of the time, I have a nice, clean sleeve there. This is going to require a little more cleaning. I'm simply going to dust it all off in my garbage can, make sure it's ready for the next one. So look over here. If I didn't make sure that was gone, it's going to create a problem. There's my, has a bunch of stuff on it. I haven't cleaned it. Let me do another one. Maybe I can do a cleaner one. Sometimes I pride myself on the fact that I get that thing looking like a straight piece of paper. Place it in the groove, measure it out a bit, close it. Wow, that was too much effort. You can see right there, came off just fine. That was pretty much, that was one of the cleaner stripping. I'm still going to run my solvent over it, get a nice, sometimes you'll see those fibers bunched together. I don't know if you guys can see that. And try to get this in focus. Run it on the back of your finger gently, just feather it a bit, they'll line out. And then simply throw it in your cleaver. What's beautiful about these holders is once I place it in there and strip it, I'm never going to move it. It's going to cleave to the right length. It's going to sit in the V groove, or the V groove. It's going to sit in its groove, the proper length. Everything's fine. Once I put it in here, I strip it, I clean it, I cleave it, and I fuse it without ever taking it out. Any other questions?
The screen has gone a little laggy, but we do have a question of cleaning, which you kind of showed for the stripper, but cleaning of the cleaver and the machine again, just proper things that you want to look for and to check.
Okay, I would always,
cleaning.
I will tell you, always refer to your user's guide. I am not an expert on how to work all the machines, but when it comes to the Tensile unit, a visual inspection, and we're going to use the ribbon slicer. Visually, I'm looking at, hold on, I think I got a little poker thingy. I'm looking at each, there's a little, these are all little grooves, there's 12 of them. So I'm looking at the grooves and see, do I see anything standing out? If my glass can't lay flat in those grooves, I'm going to have a problem splicing. So the Tensile unit comes with this little nylon brush. I'm going to run over it, make sure to run in the grooves, get everything out. If I've been using it for a long time and things just aren't, you know, my splicing action, my arcing, everything's looking kind of bleh, I'm going to go ahead and thumb screw out my electrodes. I'm going to use the cleaning supplies. I have, like, you know, I have an eraser. I have, you know, let's see, the wheels. I have replacement electrodes. Manufacturers give you the stuff you need. I'm going to do a visual inspection. If I see things like my electrodes are dulling, they're blackening, if I can look straight into that well and I see stuff sitting there, well, I'm probably going to take off my electrodes, open up this cavity, take a swivel stick, Q-tip type thing, make sure my camera lenses are clean, make sure everything in there looks good. I'm not required to take a screwdriver and take this thing apart. If my cameras aren't functioning, if things aren't going on the way they're supposed to, I might have to call tech support. But for the most part, most of my problems are going to be able to be done very easily with a couple screws, and again, they're thumb screws, and making sure it's clean.
Would you use, we have a question here, is would you use canned air to clean that machine?
You would never use canned air to clean this machine. Canned air, compressed air is in communications, we deal with microns of debris, dust debris, things you can't see with the naked eye all the time. If you use pressurized air, these wells, they have a bottom. I'm not going to force anything anywhere on this splicer. So I'm going to be using the gentler cleaning method, you know, the Q-tips, the solvent, but never, ever use compressed air. If it looks real dirty, use your brushes, use a lint-free material. These are lint-free. Your swizzle sticks are lint-free, but never use compressed air on this equipment. Your optics, your cameras, it's all very delicate. So compressed air can cause big damage. Any other questions?
Yeah, there's one more question that came in. Is alcohol an approved solvent, and what type of alcohol, if so?
So isopropyl alcohol was an industry standard for a long time, and people still use it. I feel that it's what is it, hygroscopic. It can be drying. So now I look for cleaning preparations that are specifically designed for glass. So here is a fiber prep fuel. They call it fluid, I'm sorry. And it is fast drying, it's static dissipating, and it has solvents in there, almost like little conditioners to make sure your glass isn't getting brittle. So again, we used to say isopropyl alcohol. I used to have a little container with the pump lid. We labeled it alcohol, and it was fine. But we have found in keeping our networks up and running, you know, we don't have the privilege of going and saying, oh, look, we're going to run 400 gig across this span. Let's put in some new fiber. A lot of times we have to use what we've got. And with the requirements and demands on these networks, when it comes to the optics, when it comes to the connectors, everything involved, we want to make sure that we're getting the most life out of this simple little thing, glass. Any other questions? If you guys have fusion splicers that are manufactured by Fitel and you are having any issues with them or need to know more about some advanced settings, navigation, functionality, give us a call. Like I said, I can't speak on the other manufacturers' equipment. One thing they all have in common, though, is their job is to make sure you guys can get that stuff in, get it in efficiently, get it in quickly. And when we do these designs, how do we one-up each other, right? Well, I have a double oven, my oven heats faster, I have a touch screen, I have Bluetooth. You can have all the features in the world, but it's all what happens in here. And if this is working fine, you're working fine. Splicing in and of itself, back in the day, God, I am a grandmother, but it's funny when you tell stories like, I'm now part of a generation or a career that we did things the old-fashioned way, right? We have mechanical splices. We used index matching gel to make sure that these things could fuse together better. We come out with fusion splicers. I learned on a 40S. That's where I learned, a little Fuji 40S. And, you know, how do we improve? Well, we improve the technology. We improve, you know, the arcing. We improve the heat. We improve the efficiency. But at the end of the day, if you guys aren't doing right by your equipment, it doesn't matter. It doesn't matter what you're using. Any questions? Any comments? Any concerns? Any feedback?
Doing a webinar right now.
Pardon?
Nothing has come in, Tammie, so I think everybody has their questions answered. I'm sorry, I didn't quite understand that. Any final thoughts, Tammie, to send the people off? Are you there?
You guys are the reason we have the ability to communicate across the world. And again, you have a lot of tools at your disposal, but you guys also are one of the control centers of those tools. And it's our objective to make sure that your tools aren't your cumbersome part. You're getting up in the middle of the night. You're taking care of stuff. You've got people breathing down your shoulder. We've got 911 traffic. We've got this. We've got this. And you guys can only do so much. But you're the reason these networks operate. And it is a combination and a consolidation of everybody involved. But if you guys don't have the right tools, it doesn't matter who's making equipment, right? If we don't have a good physical layer, your Ethernet, your Wi-Fi, your cellular, none of it matters. And basics, these are the basics, right? If you're testing, basically, you need at least to know TDR. Or you actually, at the least, you need a power meter and a light source. If you're splicing, fusion splicing, there's no reason to do things the hard way. You need a good quality fusion splicer. So we want to make your life easier. If you guys need anything, we're a phone call or an email away. And with that, I just want to thank you guys for your support and attending this webinar.
Thank you, Tammie, for sharing those that information on splicers for everyone. Again, we've been recording this. We will send you. We will also have Tammie's contact information on that email. And so if there's any questions that do come up, if while you're doing your splicing, you have any questions, please feel free to reach out to us. We'd be happy to help. And with that, I will bid you all a good day and have a good, safe rest of your day. Thank you and goodbye.